Okay, in this video I'm going to continue on with exercise 5A of the book Fundamental Applied Mathematics. We're on page 118 and the question is 10. It reads, a bullet is fired horizontally at 300 meters per second. It enters a piece of wood which is 10 centimeters long and emerges at 200 meters per second. If the resistance of the wood is 2500 newtons, find the mass of the bullet. So the first thing we need to do is to draw a free body diagram or a sketch of all the forces involved in this motion. So we know that, say this is our block, like so. We know that the maximum resistance force of the wood is 2500 newtons. So we have this direction. I'm going to say the motion of the bullet is to the positive bi-hat direction. So this is negative 2500 newtons in the i-hat direction. We're told that it enters the wood at 300 meters per second, which I'll draw in blue. Like so. And we know that it leaves the wood at 200 meters per second, so it's moving like this. So V prime is equal to 200 meters per second in the i-hat direction. We know that the length of the wood is 10 centimeters. Now once again we must go into SI. So a meter is 100 centimeters, so we have 10 over 100 giving us 1/10 of a meter. Alright, so just be wary of that. So we have 1/10 of a meter, so 0.1 meters. And is there anything else which we're given? No. Alright, so let's just analyze this. Okay, now the first thing we know is, if from Newton's second law says, well, it's by Newton's second law. Newton's first law, it said basically that a body will continue at uniform velocity or at rest unless a force acts upon it. Therefore, from Newton's first law, you can say that if the velocity changes, you have a force, okay? And if there is no force, you have no acceleration. Therefore, if you have a force, you must have an acceleration. So in this case, we have a force of 2500 newtons in the negative, or in the negative i-hat direction. Sorry, that should be a negative sign there. That means that we have a deceleration. We must have it. All right. So that's how we apply Newton's first law. Then to apply Newton's second law says that the sum of the forces is equal to the mass times the acceleration. We're given the force, so the sum of the forces. So the sum of the forces is equal to negative 2500. We have the mass. Okay, so the mass is the mass of the bullet, because that's what it's decelerating. And the bullet is, what did we say it was, did we have a mass? No, we don't actually have a mass. So I'm just going to say it's m. Do we know anything else? No, we don't. So we don't know a at the moment. So we need to find out what the acceleration is. So in order to do that, we go to UVAST. Alright, so let's go to UVAST. UVAST. The initial velocity was 300 meters per second. The final velocity was 200 meters per second. The distance traveled in that deceleration was 0.1 meters. So let's find the deceleration. If we use v squared is equal to u squared plus 2as, this should work. So we get 200 squared is equal to 300 squared plus 2a times 0.1. So if we have 200 squared minus 300 to be squared, all divided by 0.2, we should get our acceleration. Alright, so let's just pull out the calculator. So we get 200 to be squared minus 300 to be squared. Divide that by 2 times 0.1, and you get the acceleration is equal to negative 25 or 250,000. Negative 250,000. Alright, so I'm just going to note this down here out of the way. Of course, the unit on this is meters per second squared. Units are very, very important. So that seems to be a very, very large deceleration. So let's just apply that to what we already know. We know that we have a force, and now we can get the mass as a result. So we have negative 200 or 25,000 is equal to the mass times negative 250,000. So you have 25,000 over 250,000 is equal to the mass. So cancel the zeros. So we get 25 into 250, so what's that, 10 is it? So we get the mass equal to 10 kilograms. That can't be right. 10, or the other way around, it's a tenth. Sorry, one second now. 25 divided by 250. My arithmetic is terrible. So it's a tenth of a kilogram. Now, of course, just to tell you as well, you would know, obviously if I get 10 kilograms, a bullet of 10 kilograms would be utterly ridiculous. So you know, of course, that if you get a mass of a tenth of a kilogram, you're about right. Okay, so we're doing well so far. We've gotten the deceleration, and we have the mass of the bullet. So what are we asked to find? Okay, we're asked to find the mass of the bullet first of all. So just let me go to the back of the book and check the answers there. So it's 5A question 10. Yeah, 100 grams. Yeah, a tenth of a kilogram is 100 grams. Alright, so next we're asked to find what is the shortest piece of the same wood which could have brought the bullet to rest. The shortest piece of the same wood. Okay, so what I'm going to do is I'm going to modify the diagram I have in front. And it's going to have as follows. So we're going to say it's going to come to rest inside the wood, and we're going to say that we don't know what the distance of the wood is. Alright? Now in terms of it's the force applied by the wood, so the force of the wood on the bullet, is that going to change? And the answer is no, because it cannot change. It'll change the like if you look at force is equal to mass times acceleration. Alright? And because we haven't changed the mass, then the force cannot change. So we're going to have the exact same force imparted to the bullet. That's the first thing. So that means you have the same deceleration. So if we go to our UVAST and we do the following, we say 300 is the starting, it finishes at 0. We know the acceleration was negative 250,000 meters per second squared, and we're asked to find the distance. Alright, so we can use v squared is equal to u squared plus 2as, and we're going to get 0 squared is equal to 300 to be squared minus 2 times 250,000 times s. Therefore s is equal to 300 squared over 500,000. And s is going to be equal to, so just pull out the calculator, so you have 300 to be squared, and you need to divide that by 500,000. We get an answer of 0.18. Now if we look at our units, what is that? That's 0.18 meters, or you could say that is 18 centimeters. That's the answer given in the back of the book. Alright, that was reasonably straightforward. Thanks for watching. Please pass it on to your friends and subscribe to my channel.